to rule number 7. Rule number 7 is conjunction. We'll just abbreviate it C-O-N-J for short. Conjunction really goes in the reverse direction as compared to simplification. In simplification, you break apart the dot, getting out the first conjunct by itself. In conjunction, you're allowed to jam any two things that you like together with a dot. For instance, this will be just a generic example, visual explanation if you like, of conjunction. If on one line we said, say we had A, on some other line we had B, what simplification allows, or conjunction rather, what conjunction allows us to do is jam those two lines together. Therefore we get A and B. And the justification here would involve two lines, in this case 1 and 2, and the rule conjunction. And that's all there is to it. Reverse order of simplification. Rather than breaking apart the dot, you put two things together with the dot. Instead of saying ham and eggs, therefore ham, what you're saying is I've got ham, I've got eggs, put the two together, therefore I've got ham and eggs. And really conjunction is just as simple as that. The order in which you jam these two things together doesn't make a difference. If you like, you can get A and B, or you can get B and A. And further, as is always the case, these two lines need not be right next to each other. You can jam together lines 27 and number 11 if you like. It doesn't make a lick of difference. Any two things you like. Further, you can jam together two statements which are individually complex to get something that much more complex. For instance, you might have to do something like this. Suppose on line number 1 you had A horseshoe B, and on line 2 you had L triple bar N. We saw that exact combination in an earlier problem. Well, we could jam these two together with a dot via conjunction as well. I could, if I needed to, if I wanted to, say, therefore A horseshoe B and L triple bar N, making sure to clearly identify that dot as the main logical operator. Justification 1 and 2, conjunction. So we can jam anything, any two things that we like together, including things that are complex. So that's conjunction, really quite easy, and that's all there is to it. Moving on then to rule number 8. Rule number 8 is addition, for short, add, ADD, addition, add. What addition allows us to do is say the following, or whatever you like, or whatever you like. In that sense, you add on a new variable which isn't present. So for instance, just a generic example here, certainly there are more complex cases, but say we started with line number 1, we're given an A, and we're asked to derive A or B. Well, there's a variable that's not given to us in line number 1, so how the heck are we going to introduce it into the picture? Well, that's precisely what addition allows us to do. We can now say via addition, A or whatever you like. In this case, we want to introduce B, so we happen to like B. And that's all there is to it. Justification just involves, kind of similar to simplification, just a single line. In this case, line 1, and the rule add ADD. Now this rule seems as though you're cheating, but again, think of it in terms of chapter number 6. If we assume that the value of A is true, what's going to be the value of T, A, plugging in T for A, T or question mark? Well, that too, regardless of the value of B, is also going to be true. Therefore, this rule, and you can test it out via a full truth table if you like, that's going to be valid. If we start with something that's true, we're going to end up with something that's true. But again, can't emphasize this enough, on addition, you can add on whatever you like. Now, of course, the question is, what do you like? What do you want to add on? Well, it depends on where you need to go with it. It depends on what you need to get in order to derive that conclusion. In this case, we wanted B, so I chose to add on a B, and that's all there is to it. You can, if you need to, add on statements that are complex. So if I needed to, say I start again with an A, I could add on literally anything I like. I could add on A or say C horseshoe D, something complex here. Just so long as the main logical operator ends up as the wedge, you can add on whatever you like. You can even add on something that's negated. Maybe I start with A, and I choose to add on A or not C. Well, whatever I like, in this case, I happen to like not C, but keep in mind you can always do addition, but of course you're only going to do it if it leads you somewhere, if it gets you closer to solving the problem that you're currently trying to unravel. So that's addition. Seems like you're cheating, but think of it in terms of your truth table, and I think you'll see clearly that it does in fact stand to reason. So that just leaves us with our complicated rule here in 7.2. constructive dilemma. Let me start with the visual explanation. Constructive dilemma looks something like this. A horseshoe B and B horseshoe C. Premise 2, we need a wedge statement. We need A or B, and what we're allowed to get out is the leftover part, so to speak, speaking really quite loosely, quite generically, B or C. So that's the visual explanation. At this point, probably doesn't make a whole heck of a lot of sense. So what do we need? What do we need to do constructive dilemma? Let me now give you the verbal explanation. Well, to do constructive dilemma, you need the following pattern. Following conditions must be met. Number 1, two horseshoes joined by a dot. And that's precisely what we have here in this generic example of constructive dilemma. Two horseshoe statements, A horseshoe B, B horseshoe C, nothing magical about the variables, I just made some up to plug in. Joined by a dot, the dot here being the main operator. So two horseshoes joined by a dot. The second condition that needs to be met is that you need the antecedent to each respective horseshoe joined by a wedge. Antecedent of each horseshoe joined by a wedge. And that's exactly what we have here in line number 2. Antecedent of our first horseshoe is A, antecedent of our second horseshoe is B, and in line 2 I've got those two variables linked together by a wedge. What we're allowed to get out for a new line is the consequent of each horseshoe joined by a wedge. Consequent of each horseshoe joined by a wedge. In this case, the consequent of our first horseshoe statement is B, consequent of our second one is C, and that's what we're allowed to get out, B wedge C. So that's constructive dilemma. Quite difficult to spot, but that's the pattern that you're looking for. It's a rule that doesn't come up all that frequently, but when constructive dilemma does come up, it's the key to solving the whole problem. So you'll have a tendency, I suspect, to completely forget about constructive dilemma because it simply doesn't come up that frequently, and then you'll want to pull your hair out because, as it turns out, that'll be the whole key to unraveling the problem. So it's kind of tricky, but it's not all that